So, good day, sir. I'm Wendel Bulledo and from CEAT 29601E. So, first, what is information theory? Information theory is founded in the middle of the 28th century. Then, the foundation of information theory was laid in a 1948 paper by Shannon titled A Mathematical Theory of a Communication. Shannon was interested in how much information a given communication channel could transmit. So, interested Shannon was interested so that it used information theory. It was founded by Claude Shannon toward the middle of the 28th century, like what I said before. So next, information capacity. In electronic communication channels, the information capacity is the maximum amount of information that can pass through a channel without any error. And it is a measure of channel goodness. The actual amount of information depends on the code to how information is represented. The Shannon capacity theorem defines the maximum amount of information or data capacity which can be sent over any channel or medium. For example, wireless, coax, twistor pair, fiber, or etc. So this is the formula of the said theorem. C is the maximum achievable data rate. The units of this is bits per second. B is the radio channel bandwidth. Unit of this is hertz. Log 2 1 plus S over N or signal to noise ratio. So, and other, if the given is decibels, convert it first to watts before getting the maximum data rate. So this is the sample problems that I made. Number 1, telephone line has a bandwidth of 3 kilohertz and a signal to noise ratio 30 decibels. What is the maximum bit rate or capacity of the line? So we all know that 30 decibels is equals to 1000 watts. So I solve it. This is my solution. C is equals to 3 kilohertz log 2 1 plus 1000 is equals to 3 kilohertz multiplied by log 2 1001 because 1 plus 1000. Log 2 1001 is equals to 9.97. 3000 because 3 kilohertz. 3000 multiplied by 9.97 is equals to 29.9 kilobits per second. So this is the maximum achievable data rate that we acquired, 29.9 kilobits per second. So the next sample problem that I made, a Gaussian channel has 1 megahertz bandwidth. Calculate the channel capacity if the signal power to noise spectral density ratio to signal to noise is 10 raised to 5 hertz. Also find the maximum information rate. So this is this is my solution, and this is the first. We use the formula C is equals to B log 2 open parenthesis 1 plus signal to noise ratio. So the signal to noise ratio on this given is equals to 10 raised to 5. The radio channel bandwidth is 1 megahertz. So the solution 10 raised to 6 because 1 megahertz is equals to times 10 raised to 6. Log 2 1 plus 10 raised to 5 because the signal to noise ratio is 10 raised to 5 input here. 10 raised to 6 log 2 using logarithmic formula or logarithmic function 10 raised to 3 times 10 raised to 2. 3 plus 2 is equal to 10 raised to 5. We factor out. Then 10 raised to 6 log 2 1000 log 2 raised to 1000 plus log 2 raised to 100 using logarithmic formula or logarithmic functions. 10 raised to 6 log 2 2 raised to 10 because 2 raised to 10 is equals to 1024. We need 1000. Approximately we can use it 1024, but we need 1000, so it is okay to use the 2 raised to 10. Then log 2 raised to 100 is equal to 6.6. Then calculate 10 raised to 6 log 2 2 raised to 10 is equals to 10. Then 6.6, and solve it on calculator, is equals to 16.6 megabits per second. So the maximum achievable data rate we acquired here is 16.6 megabits per second. So the third sample problem, a satellite TV channel has a signal to noise ratio of 30 decibels. So 30 decibels, we need it again to convert it to watts, has a bandwidth of 20 megahertz. Solve for the maximum data rate of the channel. So the 30 decibels, we convert it, is equals to 1000 watts. Though, using the formula again, hence substitute the given 20 megahertz, so it is 20 times 10 raised to 6 because it's megahertz. Then log 2 using the formula 1 plus 1000 because the 30 decibels equals to 1000 watts. Then solve it from the calculator. The answer would be 199,344,525.2 bits per second. It is the maximum achievable data rate we acquired. So the last sample problem on this topic, for a typical telephone line with a signal to noise ratio 20 decibels, what is the required bandwidth to achieve the maximum data rate of 5 Mbps? So solve. 20 decibels is equals to 100 watts. So the formula again, C is equals to B log 2 1 plus S over N. So 5 times 10 raised to 6 because it is megabits per second. That is the maximum achievable data rate in the given. Is equals to B log 2 1 plus 100 because 100 watts. So we derive it to define the B, or the radio channel bandwidth. So this is the formula when we derive it. B is equals to 5 times 10 raised to 6 all over log 2 1 plus 100, then put it on calculator, then solve it. The radio channel bandwidth will be acquired of 75952.4161 hertz. And that's all, sir, and thank you.